Yeah, so today is basically going to be solving questions mostly. Um, yes, we are majorly going to be solving questions a lot of questions today. We Let's start with some recap or some things I want to reiterate from yesterday's session. So specifically the external equations, right? Something escaped me. The equation, right? I wrote this: S is equal to V minus U all over T. It's not supposed to be S, it should be A because that's the definition of acceleration. Is acceleration. And then S is rather equal to half into bracket U plus V multiplying T. So this is the correction that we need to keep in mind.
Okay.
Yeah. Okay. So um now now that I have there's another thing that you also need to keep in mind whenever we are reading a question and they said a body decelerates, you decelerate, or they say a body breaks like a car has applied, the brake has been applied. So what happened for the value that is going to affect the value of the acceleration, specifically the sign of the acceleration. If there is acceleration, but if you are doing braking or coming to a stop by decelerating, the value, if the value was +2, if it was acceleration, but if it is decelerating or a brake is applied, the value of the acceleration become -2. So that braking is the negative side. That's what we need to keep in mind, that whenever we are braking, we need to apply the negative sign of the um for the acceleration. Is that fine?
Yes, please.
Good, good, good. So let's go and solve a lot of. I've prepared some number of questions, but do you have any question that you have?
No, please.
Sure. So let's start the questions. Let's start the questions. I have this question. We are going to solve from the simplest one to the top. So there will be increasing order of difficulty. That's how the question will come. So let's start with these basic ones. So first, remember the equations of motions, right? Can you remind me? The first one is what?
Okay, so the first one is V is equal to U plus 80.
Okay.
Then the second one is equal to S is equal to UT plus half 80.
Is half 8t squared. The second t is
Okay, okay,
squared.
okay. And the third one is V squared is equal to U squared plus 2AS.
Okay, good. So you have the basic equations I have in mind. Now we are going to use this equation to solve the question. So when you are reading a question, you note down the parameters. The parameters are the key values that you need to do your operations. So they say a car starts from rest. Whenever you say something starts from rest, it means that the initial velocity, when you start something from a rest or from the beginning, meaning it started from rest, it was not initially moving, meaning initially it was not having any velocity. So the initial velocity u is 0 meters per second. That's what you need to keep. Whenever it's starting from rest, initial velocity is always 0. Okay. Another term is the body comes to rest. The body starts from rest. That's initial velocity is rest. That's initial velocity is 0. But the body comes to rest. It means that the final velocity v equal to 0 meters per second. So if it comes to rest or come to stop, so this one is from rest. But this one to rest or to a stop, that's all we know, that final velocity is equal to 0. So those are the things that you need to keep in mind. Those ones are hidden, so you will not see it as value in the equation. But for example, this one they say a car starts from rest, So when they say from red, they have given us u already, which is 0. Is that okay?
Yes, please.
Okay, sure. Now, so and then accelerate at 2 meters per second squared. Accelerate. So they're giving us acceleration a is equal to 2 meters per second squared. How far does it travel in 5 seconds? So they have given us t to be equal to 5 seconds. So you can see that from this thing alone, they are looking for how far does it go, how far does it travel, how far. They are looking for distance. So they are actually looking for s, and then they have given us u, they have given us a, and they are giving us t. So now these are the one that they have given us, and they are looking for s. So we need to take these three things that they have given us into the equation and see which of the equation we can use. So for the first one, let's test on the first one. On the first one, they've given us u, they've given us a, they've given us t. So we can use that to find v easily. But then we are not actually looking for v. They are actually looking for s. So let's go to this equation. They've given us u, they've given us t, and they've given us a. We can see that this one too is also valid because only one thing is missing, and what they are looking for is distance. So this equation is best suited for this particular question. Do you understand?
Yes, please.
Okay. Abdul, can you hear me now?
Yes, I can hear you.
Yeah. Okay. So I was saying that should I call the Abdul or I should call the Seidu or Aziz? Which one?
Abdulaziz.
Okay. Okay. Sure. Welcome.
Thank you.
So yesterday we had a session starting emotion yesterday. So we've actually explained the concept. Today we are just coming to solve questions. I don't know whether we have the video that you've done yesterday uploaded. Have you seen it in the channel?
Yes, I saw it.
Oh, okay, sure. So you can always catch up when you miss any class. Okay, let's continue.
Okay.
Yeah. So yes, so we are able to use those ones to determine that the equation 2 will be the one to help out. So once you get the equation, then the rest of the thing is to use that equation to find whatever they are looking for. So I'm trying to um, show you how to go about solving the questions before we solve it together. So first we write the parameters. So the key parameters are so they give us u equals to 0, they give us a equals to 2, and they give us t is equal to 5 seconds, 5. Then they are looking for s. So s is what they are looking for, and we have determined that is this equation that will help us. So putting that into perspective, into the equation, u is 0, so it's going to be like 0 times t is 5, plus half a, the value of a is 2, and the value of t squared, which is 5 squared. So if you have that 5 squared, this one is going to be 0. 0 times 5 is 0, plus half times this is going to give us 25. So because it is distance, right? So the final answer should be 25 meters because they are looking for distance. And then you have to also keep in mind that what is the running equation, the running unit inside the leading unit inside the question. So here is meters, right? Meters is the one running when it comes to distance, and for time is in seconds, basically. So that's why our distance finally we give it meters. If this one was kilometers per hour and this one was 5 hour, our final distance should have been kilometers. So that's how to select the unit for it. We have a video on our channel already that covers how to get the um, equation. Is someone having any question? So anytime you have a question or you have a concern, you can always raise your hand um, by pressing the hand button. Hello,
Okay.
can you mute yourself? Robinson, Ruto, can you mute
Yes.
yourself? You are welcome though.
Yes. Thank you, sir.
Okay, coming to you. Let me help you. So whenever you have any question, you can always raise your hand and ask your questions. So now that was the
Okay,
first
sir.
question. That was the first question. Let's go to the other questions. This is a very simple question. So the next one, let's follow the same procedure to do that. Um, so for this question, I don't know whether I should give you guys some time, but then let's get the parameters together. A bike moves with constant velocity of 10 meters per second for 8 seconds. So the obvious one that we can see over here is that they have given us, they say constant velocity. Maybe I think we should mute ourselves for now if we don't have any question. So I'm helping you do that. Yeah, thank you. Um, so a bike moves with a constant velocity of 10 meters per second for 8 seconds. So we know that t is equal to 8 seconds. How far does it go?
Yes.
How far? Whenever they say how far does it go, they are looking for distance. How far does something go? So it's going to be they are looking for distance. And they talk about constant velocity. We need to be very careful about this question. The question is saying constant velocity. Constant velocity means that whatever you start with is the same thing that you are using. The same thing exists. It doesn't change over time. So it means that the initial velocity and the final velocity are going to be the same. Initial velocity and final velocity are going to be the same. Whenever you are doing constant velocity, whenever you say the thing is constant, sometimes they don't use constant. It moves with a uniform velocity. So if you don't see the word constant in the question, they can say it's moving with a uniform velocity. So it can be constant or uniform velocity. So for those ones, what you have to keep in mind that okay, whenever they did that, it means that the initial velocity u is equal to the final velocity v, and in this case that value is 10 meters per second. So that value is 10 in this case. So whenever you see constant or uniform velocity, it means that the initial and final velocity are the same. So the value for u is 10, the value for v is also 10. Let's keep that in mind. Another thing to note is that whenever they say constant velocity or uniform velocity, acceleration is zero. Acceleration is zero because we learned that acceleration is equal to v minus u all over t. But if it is constant velocity and these values are the same, for example 10 minus 10 is going to give us 0 over t, whatever time is, and 0 over any number is 0. So whenever you hear the word constant velocity, not constant acceleration, not constant acceleration, I'm talking about constant velocity or constant speed. Whenever they are talking about constant speed, please keep in mind that you have three values given to you. They have given you the u, which is that same value, the v, which is that same value, and they give you a, which is 0. Whenever you see just that one, you have three things that you can deduct from it automatically. Are we good? Someone has a question? Yeah, go ahead.
So for this question, is it necessary to use external formula?
Um, so you wanted to use the external formula, right? What are they looking for? How far does it go? S, right? Which is equal to
Yes.
half u plus v all multiplying t, right?
Yes, please.
Let me see. So we are going to use this external formula to solve it and use the other one to also solve it to see if okay.
Okay.
Okay, so let me solve the questions so that you can confirm. Let's first start with the s thing. But then do you take note that whenever they say constant velocity, it means that you have to deduct three values from it automatically. You don't have to think twice. So whenever they say constant velocity, u is 10, u is that same value. Here in this case it's 10, so that u is 10, the V is also 10, and A is 0. This is automatically deducted from just that one clue they give you. So let's use this equation that Kennedy suggested. We learned about it yesterday. Okay. So S is equal to half 10 plus 10, or multiplying T is 8, right? Okay. So we are going to have this will multiply this, then you are going to have 80 meters. Is that what you can put that in your calculator and see? I got 80 meters. Verify that. If anyone can verify that, kindly confirm for me. Um, can you all confirm for me, please?
Please, I got 8 meters.
Okay, sure. Now let's use the other formula. The other formula where they've given us U, they've given us T, right? Which of the equations should we use? We are looking for S.
Hello.
Yes. Yeah, Alice, are you saying something?
Please, I think that the screen is not clear, please.
The screen is not clear.
Yes, please. The voice is not clear.
Okay, okay. Is it better now? Alice, is it better now?
Yes, the
Okay. So what happened is that
voice.
when you put your camera on, it's going to affect your network. So put it off so that you can enjoy the hearing of it, right? Sometimes some areas that what happens. So you can switch the video off. Switch your video off so that the thing will focus on just the hearing. Are we okay?
Yes, please.
Okay. So yeah. Um. So let's solve the other one. Let's solve the other one. We're using this equation. So Kennedy, which equation do you think that we should use? Which equation do you think that we should use? We have a lot of things here, so I think I can still use S is equal to UT plus half AT squared.
8 square.
Yeah. So it's going to be S is equal to U is 10 times 8 plus half times A is what? What's the value of A?
0.
0. So 0 times T squared, which is 8 squared. So 0 times any number is 0. So S is also going to be 80 meters. Right? You see the two of them give you the equation. So you can go about this method, the external equation, or you can still use the internal equation that we've learned. Are we fine?
Yes, please.
Okay, good. Let's go and solve another question. This is another question that we are solving. So this question says that a runner increases speed from 4 meters per second to 10 meters per second in 3 seconds. So we need to write down the parameters again.
Okay, I'm fine.
Hello, is someone calling me? Okay. Okay, let's mute ourselves. If you have a question, you can unmute and then talk, okay? You can mute yourself so that you help us. Click on the mute button, the microphone button. Let me help you mute yourself. Okay, sure. So what happened is we need to be very careful with this question. We need to note the initial velocity and the final velocity. So they say the person increases the speed from somewhere to another velocity. So the from no is the beginning velocity, that's u equals to 4 meters per second. And then the other one, which is, so we know the from velocity, and we are going to the to velocity, to v equals to 10 meters per second. So let's take note of that. They have given us the initial velocity and the final velocity. So the initial velocity is the u, because they say a runner increase speed from this to this, from 4 to 10, meaning that the person started from 4 and went to 10. So we allow you to note the u and the v at once. And they give us t, which is equal to 3 seconds. So now they are looking for what is the acceleration. They are looking for a. They are looking for a. So this one, you have a lot of equations in our hands that we can use. So we have v is equal to u plus at. We can also use the external equation, which is basically from this, a is equal to v minus u all over t, right? So any of the equation, this is the same as this, just that they made a the subject this time. So if you are using this equation, this of the equation that we've learned, we see that a is equal to v is what? V is 10 minus u is 4, u is 4, v is 10, and t is 3. So that will give us 10 minus 4, that will be 6 over 3. 6 over 3, that will be 2. Acceleration is in meters per second squared. The unit of acceleration is in distance per second squared, so per time squared, so it will become 2 meters per second squared. Do you have any concerns so far?
No.
Okay, good. That's Now let's go to the next question. So you just basically write your parameters. If you're able to write your parameters down and you know you have the equations at your fingertips, I promise you it's very easy to just solve any question. It's very easy to solve any question. So let's go to the next one. This one says a track moving at 20 meters per second. So the track is already moving at 20 meters per second. So it means that they have given us the initial velocity of the track, 20 meters per second. So you need to recognize your parameters. For the next one, I will allow you guys to help me identify the parameters. I've solved about 3 questions so far to help you to see how to identify the parameters from the question. The next question, you will help me identify the parameters, what each value represents. If you're able to write the parameters first, before we begin to tackle the question, it is easier to use the equations that we know already. Okay, so the first step is to be able to write your parameters and label them very well. So the very first one is a track is moving at 20 meters per second, and we are saying that that velocity is u is 20. So we have it here, u already. They say breaks uniformly. Breaks uniformly. So whenever there is a braking, what happens? We say that and stops in 5 seconds. So whenever something comes to a stop, it also gives you an information. I said it earlier that whenever there is something that comes to a stop, it also gives us an information that the final velocity is 0. When something was moving at a particular velocity and they say it comes to a stop, it means that at the end it is not having any velocity again because it is no more moving. At that moment, the velocity is 0. So final velocity is 0 at that point. So those are the things that you need to take note. You read from the question how to deduct the parameters. So brace informing and stop in 5 seconds. They give us the time, which is 5 seconds. They're giving us already. So now, what distance did he cover while stopping? They are looking for S. They are looking for S from this question. They are looking for S from this question. So which of the equations do you think we should use?
S is equal to half into bracket U plus V close bracket T.
Okay, yeah, one of the external equations, right? Because this one does not have acceleration. So the missing term is acceleration, so it's fine. If you are lost why where we are getting the equations from, the yesterday session we covered that already. Um, we covered that already. Abdul, can you hear me?
Yes, I can hear you.
Yeah, so we covered that yesterday in yesterday's session. So you can quickly go back and then refer to that. That's why we have the equations in our hand. That's why he's mentioning it like that. Are you fine?
Oh,
Yes,
yes, I'm fine.
great. Um, so this is the equation that we have. So we need to solve the equation. So what do we have? What are we going to have? If I put this in half, u is what, 20 plus 0 times t is 5. So if I do this, I'm going to have 50 meters. Is that correct?
Yes, please. Yes.
Yeah, okay. So that's correct. 50 meters. That's the answer. Now, next question, you are going to help me identify the parameters first. After you write the parameters, now you decide on, based on the parameters that you have, you decide on which equations to use. Let me write the equations again. Let me write all the equations again down here. So V is equal to U plus AT. Let me close this. This is one equation. Equation 2, S is equal to UT plus half AT squared. We also have V squared equals to U squared plus 2AS. This is equation 2 and this is equation 3. So these are the core equations of motion. But externally, we have some like A is equal to V minus U all over T. And we also have S is equal to half into bracket U plus V multiplying T. These are the core equations of motion that we use so far. So what you do is that you read the questions, you write your parameters down. Based on the parameters that you have, you choose the equation that can help you do that. Okay, so let's try with this one. A car moves with initial speed. Oh, here they have labeled it. Oh, u equals 5 meters per second. So they have given us u equals to 5 meters per second. Okay, so I'll leave the rest to you. What are the other parameters that we have? Anyone can go.
Okay, we have the acceleration to be 3 meters per second square.
Great, you have the acceleration as a parameter already. What do we also have?
And then our distance will be 45 meters.
They give the distance to be 45 meters. So that's S is equal to 45 meters. Then
Yes.
they are looking for what?
The velocity, the
Which
final
of
velocity.
which velocity?
Final.
Final. They are looking for V. So based on this parameter, they give us U, A, S, and V. Which of these equations are we going to use?
We are going to use the third one.
The third one. Yes. So
Yes.
one thing that we learned yesterday how to do the thing is that not everybody is very quick to get it. So what we do is that based on the values that they give you here, you look at the things that are available to you and you go to each of the equations. And you'll be like, okay, for this one, they've given me U, they have given me A, they have not given me T, and I don't know V. So two things are missing. If two things are missing in that equation, then you cannot use that equation. So the trick is that you should make sure that only one thing is missing in that equation. Only one thing is missing in that
Okay.
equation. So for this one, two things are missing, so we will not use it. If you go to the next one, they have given us S, they have given us U, they have not given us T, but they have given us A, right? So yeah, one thing is missing. Only one thing is missing, which is T. T is the only thing that is missing. But the question is not asking us for to find the time. So that missing thing is not what we are looking for. Right? So if you come here, the last equation, they have not given us V, they have given us U, they have given us A, they have given us S. One thing is missing, and that one thing that is missing is the one we are actually looking for, which is V. That's why we have to choose the equation 3. If any of them doesn't work, then you can proceed to the external equations. Try these guys and try these guys. That's the trick to quickly get that. Physics is not that difficult. Okay, so
Okay.
we are agreed that we are going to use the third one. So to do that, let's do so v squared. So I will do v squared is equal to this one. We have unique calculators around. U squared is 5 squared because u is 5 plus 2 times a is 3 times s is 45 meters. This one we need calculators around. Let's try, guys, try and see the value for v. Let's find the value for v. If anyone finds this, then you can mention it. Are we trying it? Are we trying the questions? Hello, my people. Are we trying the question? Abdul, Kennedy, Yaka. Are you guys trying the question?
Yes, we are trying it. I'm going to fetch my calculator.
Sure. Kennedy, how is it going at your end? Kennedy, can you hear me? Is anyone having the answer? Or it's very difficult? So this will be 25 plus, that's 6 times 45. You should have the calculator, so that will be v squared, right?
Yes.
So
So the
this,
answer will be 14.31.
you say is what?
I
Is
had
what?
it to be 14.32
3 to um what's the unit?
meter per second.
Meters per second. Guys, can you confirm if it is 14.32? Can anyone confirm? At least one person. Kennedy and Yaka. Maybe if you are speaking, you have muted yourself, so we cannot hear you. I guess they are still trying. I guess they are still trying it. So let's continue with the next question. Let's continue with the next question. So yeah. So we solve this one, and then for the last two questions, I'll give it to you guys to go and try. Go and try yourself. They are going to be the last stage of the challenge, right? Two questions for you. I have two more questions that after this one, so you can go and try it. So that we know we have covered the basis of linear motion on the ground. This is linear motion on the ground. So tomorrow we'll continue with motion upward, up, down, like motion under gravity, basically linear motion under gravity, free fall, and all that. We'll cover the concept, and then we'll meet again and solve a lot of questions again to make sure that we understand we are using the equations very well. Okay, for this question, for example, a van is traveling at 15 meters per second. So they given us the initial velocity, u is equal to 15, slows down at 2 meters per second squared. So slows down. I said something at the beginning today that so the acceleration, this is in 2 meters per second squared. The 2 meters per second squared, the square is telling you that this is not a velocity, it is an acceleration. So a is equal to 2 meters per second squared. If it is just meters per second, then that's velocity, but meters per second squared, that's acceleration. And then we also said today that whenever they say we are slowing down, whenever we are slowing down or we are decelerating or we are braking, the acceleration should actually carry a negative value. It should be a negative value. So whenever they say that okay, a body is decelerating, a body is braking, or a body is slowing down, it means that it is decreasing in velocity. So the acceleration should actually be a negative value. That's the case. But if they say the body is accelerating, that's will be a positive value. But yeah, whenever they say slows down as a particular acceleration, make it negative value. Note that it is only the acceleration that you have to make negative. Don't go and make the initial velocity negative. Don't go and make the final velocity negative. It's only acceleration that you need either make it negative or positive based on the question. But this question is saying that we are slowing down. Because of the slowing down, then we need to give it a negative value. Are we okay on that?
Yes.
Okay. So let me. So a u is equal to 15, a is equal to -2. How long will it take? So they are looking for time physically. How long? How far? That's a question referring to distance. How long? That's a question referring to how long will it take um to reach 5 meters per second. So they give we want to reach a velocity of 5 meters per second. That's basically, and what distance will it cover in that time? Then you are looking for what distance will it cover in that time. So they are looking for two things: time and distance. They have given us u, they are giving us a, they are giving us v. Which which of the equations are we going to use? Now that becomes the question. After you write your parameters down, now you focus is your next headache should be now what equations are we going to use? Let me write the equations down again. V is equal to u plus at, s is equal to ut plus half at squared. If you solve questions like this, you'll be to get to a time that you'll be used to the equations of motion easily, plus 2as. So which of the equations are we going to use? So they are looking for time and they are looking for what again? Distance. So first, let's look for time. If I go to this equation, if I go to this first equation, V was given to me, yes, correct. U was given to me, correct. A was given to me, correct. But T is the only missing thing, and we are looking for T. Can we use this equation to solve it?
Yes.
Okay, so if we go by that, V is equal to U plus AT, and the value for U, V is 5, equals to the U is 15. The value for A is -2, so I'll do -2T, because negative and positive, the negative will take over. So we'll have this. Now let's solve this. This one is just mathematics. Make so 2t will be equal to, I carry the 2t to the other side. So I have 15 minus 5 on this side. Put the 5 over here. So 2t is equal to 10. This means that t is equal to 5. What's the unit? What unit are you giving it? It seems we are having network issues. Yeah. So we are going to basically give it this a time of 5 seconds. It's within time of 5 seconds. So yes, we go with that. Nice one. Then we need to find a value for distance as well. We need to find the value for we need to find distance as well. Now that we know t, we need to find the value for the distance. And for the distance, we need to use the second equation rather. For the distance, s is equal to ut plus half at squared. We know the u, we know the t now because we just found it, right? Then we have the a, so we can find the value of t. So I can use that equation. Let me see what we can have here. Mm, so we have V equals to U plus, no, is we are using the S rather. So we have the S equals to UT plus half AT squared. So S is equal to U is what? U is 15 times T is what? T is, we just found T, right? T was 5, yes. T was 5 meters, 5 seconds. That means 5 plus half. A is negative 2. Remember the negative. That means the T, which is also 5. So you can put these two things together. Then you solve it and find the value for S. So this one, 15 times 5 is going to be 75 minus minus 5 basically. So we are going to have 70 meters. So S is equal to 70 meters basically.